Can knowledge be transmitted without teachers, without books, and even without training? More than 100 years ago, a series of extraordinary scientific experiments challenged one of the most basic rules of modern biology. Scientists trained rats to solve a complex maze, and after generations, their offspring began to solve it faster and faster, without ever having seen the same maze before. Even more incredible is that similar results are starting to appear in other laboratories, thousands of miles away, with completely different animals. How is it possible for knowledge to seemingly spread between members of the same species without direct contact between them? Is it a coincidence, an error in the experiments, or has science stumbled upon a phenomenon that it still cannot fully explain? Today we will examine one of the most contested and mysterious scientific stories of the 20th century, a story that questions the way we understand memory, heredity, and the very nature of knowledge. In 1920, Harvard psychologist William McDougall conducted an unusual experiment. He placed laboratory rats in a water maze with two exits. One is brightly lit and easy to find, but leads to an electric shock. The other is dark, harder to find, but completely safe. To make the task even more challenging, McDougall constantly swapped the two exits. So the rats couldn't just memorize the direction. They had to learn a single rule: light brings pain, and darkness is safe. At first, the animals invariably choose the lighted exit and receive an electric shock. They try again and again and again. On average, it takes the first generation about 165 trials before it learns the correct decision. Then McDougall began breeding rats. The parents were not selected for intelligence. They were chosen completely randomly. According to classical genetics, the offspring would have to start learning from scratch. But that doesn't happen. The second generation does it faster, the next one even faster. After 8 generations, the average number of attempts drops to 56. After another 8 generations, up to 41, then up to 29. And by the 300th generation, the rats are already solving the maze, after only about 20 attempts. This means they learn more than 8 times faster than their ancestors. McDougall decided to test whether the result was due to natural selection. He began breeding only the weakest, slowest learning rats. If the theory was correct, their offspring should remain just as slow. But the opposite happened. And they start learning, faster and faster, with each successive generation. After 30 generations and thousands of experiments, McDougall published his results. He doesn't draw any big sensational conclusions. He just presents the facts. However, in his personal notes, he admits that he is beginning to doubt whether Jean-Baptiste Lamarck was right. According to Lamarck's theory, organisms can pass on skills acquired during their lifetime to their offspring. Modern biology categorically rejects this idea. Genes, physical characteristics, and predispositions are inherited, but not acquired knowledge. Yet McDougall's experiments seem to show just the opposite. But the even more inexplicable was yet to come. In 1923, Scottish geneticist Francis Albert Crewe decided to repeat the experiment. He uses the same type of maze, the same breed of lab rats, and adds a control group to avoid any doubt. The expectation was that the untrained rats would start at about the 165th trial. Instead, they solved the maze, on average, after only 25 trials. These animals had no genetic relationship to McDougall's rats. They had never been trained, and they had never come into contact with them. Yet they acted as if they already knew the solution. Similar results were later obtained by other scientists in different laboratories and different countries. It seemed that the acquired knowledge, in some way, spread throughout the species. And rats weren't the only example. In the 1920s in Britain, Tits discovered how to pierce the aluminum caps of milk bottles left outside homes to get to the cream. In just a few years, this behavior spread throughout the country. During World War II, aluminum caps disappeared because the metal was needed for the production of airplanes. Enough years passed for all the birds that had ever learned this trick to die out. But when the aluminum caps reappeared after the war, new generations of tits, almost immediately, began to pierce them, even though they had never seen anything like it before. For many, this raises the same question. Is it possible for certain knowledge to be preserved in a way that science does not yet understand? And if this is possible in living organisms, can a similar phenomenon exist outside of them? After the first successful case, glycerol began to crystallize easily everywhere. A similar story is observed with xylitol, decades of unsuccessful attempts, then a breakthrough, and then successes in various laboratories. Rats, birds, crystals. In all of these cases, the same pattern seems to emerge. Information, behavior, or form begins to spread, without any apparent means of transmission. Something must be carrying this information, something we can't see, something we don't yet fully understand. In 1981, a young scientist from Cambridge proposed a theory that would spark one of the greatest scientific controversies of its time. According to him, species can not only transmit information through space, but also through time. His name is Rupert Sheldrake. In 1973, Sheldrake was working in his laboratory in Cambridge and was observing a bean plant doing something that, according to everything known in biochemistry, should not be happening. Bean plants need a support to wrap around, a pole, wall, fence, or tree. Sheldrake grows them in pots with small wooden sticks placed as support. But one of the plants starts growing towards a place where the support has not yet been placed. It's as if the plant knows where the stick will be in the future. Sheldrake is no ordinary man. He had a research fellowship at Cambridge, worked at Harvard, had a doctorate in biochemistry, and became director of a research program at the age of 31. His research on plant hormones is used in textbooks to this day. But this plant bothers him. Plants don't have eyes. They don't have a nervous system. The support won't be in place for another 2 days. And yet the plant is already changing its direction of growth, as if preparing to climb onto something that does not yet exist. This leads him to consider a larger question. DNA does not contain a complete blueprint for the finished organism. An acorn has the same DNA in every cell, but some cells become roots, some become leaves, some become branches. All of them organize into a tree, but science can't fully explain how the cells know what to become. We can think of DNA as a set of building blocks. With the same building blocks, different shapes can be created. What matters is not just what the system is made of, but what organizes it into its final form. A fruit fly, a banana, and a human share much of the same DNA, but they develop into completely different organisms. According to Sheldrake, the final form is not contained in the DNA alone. Something else directs the process. One evening, while walking home along the River Cam, he comes up with an idea that will change his life. What if nature has a memory? When a system organizes itself, a crystal, a plant, an animal, or a behavior, it creates an invisible pattern. Sheldrake calls this pattern a morphic field. According to him, such systems can resonate with this field and access pre-existing memory in nature. So, a bird that learns to pierce foil, or a crystal that once manages to form, leaves a mark. The more times this mark is repeated, the stronger it becomes. And so much easier, other similar systems can follow suit. No physical connection is needed. Memory is already part of nature. In 1974, Sheldrake went to India, where he worked at an agricultural institute. During the day, he was engaged in his scientific work, and in the evenings, he spent time in a monastery. Over the course of 18 months, between prayers and meditation, he wrote a book in which he proposed that the universe may have memory. The book was published in 1981 under the title A New Science of Life. The reaction was violent. John Maddox, the editor of one of the world's most prestigious scientific journals, Nature, published a scathing article against the book, calling it the best candidate for burning in many years. This is highly unusual. Nature is a journal that has published scientists such as Einstein, Watson, Crick, and Darwin. The call for a symbolic book burning is almost unprecedented in the publication's modern history. Maddox doesn't just claim that Sheldrake is wrong, he portrays him as dangerous. After that, many scientists who have shown an interest in morphic resonance go silent. Students are being warned not to delve into the subject. Funding for such research is gradually disappearing, but the attack is having the opposite effect. The more the scientific community tries to dismiss Sheldrake, the more people start reading his book. The article that was supposed to destroy him turns his work into a bestseller. Years later, he was physically attacked. On April 2nd, 2008, during a lecture in Santa Fe, a man from the audience rushed onto the stage with a knife and stabbed Sheldrake in the leg. The attacker later claimed that the scientist had used him in telepathic mind control experiments for 5 years. The wound was serious, but Sheldrake survived. Just a few days later, still using a walker, he gave a lecture entitled Science and Hope. In 2013, Sheldrake gave a lecture in which he criticized what he called the dogmas of modern science, the idea that nature is mechanical, that matter is unconscious, and that the mind is merely a product of brain activity. The lecture was removed from the official channel, and a campaign was launched against it. But again, the same thing happens. The attempt to silence it only attracts even more attention. The video began to spread on other channels and garnered millions of views. More and more people began to ask the same question. What are they so afraid of? Then, a British television broadcaster decided to test Sheldrake's theory on a scale no one had ever attempted before. In 1984, an experiment was broadcast on British television. Viewers were shown a visual puzzle, a hidden picture that had to be recognized among chaotic dots. About 2 million people watched the show. Then researchers test people who haven't watched the show. Some are in other cities, others are in other countries. The results are surprising. These people solved the same puzzle significantly faster than the control groups tested before the broadcast. According to Sheldrake, the 2 million viewers created a new memory in nature, a solution to the particular puzzle. Then other people, without having watched the show, seem to have easier access to this information. He suggests that a similar effect could be observed with crossword puzzles. The more people solve a crossword puzzle during the day, the easier it should become for the next person trying it for the first time. Some newspapers decided to test this. The London Evening Standard found that their crossword puzzles were solved about 20% faster in the evening after thousands of people had already solved them during the day. Here's another curious example, the so-called Flynn effect. Since the 1920s, IQ test scores have been rising around the world by approximately 3 points per decade. Each successive generation scores higher than the previous on the same tests. The usual explanations are better nutrition, better education, and better test preparation. But improvement is observed even in pattern recognition tasks that do not directly depend on education. According to morphic resonance, the more people master a given type of cognitive task, the easier it becomes for everyone else. Sheldrake's most famous research, however, involved dogs. He documented over 200 cases in which dogs went to the door or window the moment their owners decided to come home. Not when they are already close, not when they hear the car, but when the owner makes the decision to leave. In some cases, owners come home at random times and in unfamiliar vehicles to eliminate the possibility that the dogs are reacting to familiar sounds or habits. Dogs seem to know after all. One of the most famous cases studied by Sheldrake was a terrier named JT. He was observed over 100 times. Within 10 seconds of his owner deciding to leave work and go home, JT would go to the window 85% of the time. And his mistress was about 4 miles away. Then comes another strange sensation, the feeling that someone is watching us. Sheldrake conducts 25,000 trials. Participants have to guess whether someone is looking at them from behind. By pure chance, the result should be about 50%, but they guess correctly 55% of the time. At first glance, 5% doesn't seem like much, but with such a large sample size, the difference becomes statistically significant. Almost every person has felt someone watching them at least once, turned around, and really seen a gaze directed at them. And yet, the big question remains. Is the theory of morphic resonance true? We have to start with the bad news here. The famous story about the monkeys of Koshima Island, according to which a monkey learned to wash sweet potatoes in the ocean, and then monkeys on other islands began to do the same, turns out to be greatly exaggerated. Author Lyle Watson used real observations by primatologists, but added fictional elements to make the story more impressive. And the crystals also have a possible traditional explanation. When a lab finally succeeds in crystallizing a compound, Microscopic traces of the already formed crystals can be carried on clothing, equipment, tools, or materials between labs. So, according to chemists, the process begins to repeat itself more easily in other places. Sheldrake would say these are morphic fields. Official science says these are microscopic crystal traces. Experiments with crossword puzzles and TV puzzles are also interesting, but their results are small and the methods are controversial. They do not constitute definitive proof. But then there are the rats. McDougall's data is real. Crew replicates the results. Agar also replicates them on another continent. Rats really start to do better over generations, without direct physical contact between the individual lines. Critics offer an explanation. They say that early generations were more stressed because researchers didn't yet know how to work with animals properly. Over time, scientists became more experienced. The rats were treated better, and therefore the results improved. But decades after McDougall's death, science discovered something that makes the question even more interesting: epigenetics. Epigenetics shows that experiences, stress, and learned responses can leave chemical marks on DNA and influence subsequent generations. This does not prove morphic resonance, but it does show that the idea of transmitting information between generations is not as impossible as it once seemed. Sheldrake's research with dogs remains among his strongest published work. Critics find methodological problems, but defenders argue that the results are replicable. The debate continues. The main argument of skeptics is that morphic resonance implies the transfer of information without any apparent expenditure of energy, and this seems to contradict the law of conservation of energy. Physics has rules, but not all physics is that simple. In quantum physics, there is a phenomenon where two particles can remain connected, regardless of the distance between them. Whether they are in the same room or across vast cosmic distances, a change in one affects the other in a way that, to this day, remains deeply mysterious. Carl Jung spoke of the collective unconscious, a shared layer of human experience that lies beneath individual consciousness. Physicist David Bohm suggested that all points in space are fundamentally connected. Erwin Schrödinger, one of the founders of quantum mechanics, argued that individual consciousness may be an illusion and that a unified mind exists at the core. Max Planck, Nikola Tesla, and Albert Einstein also came up with ideas in which the universe seemed more deeply connected than we usually imagine. Some arrive at this through mathematics, others through physics, still others through observation of animals, plants, and human behavior. But they all converge on the same word: connectivity. Perhaps the laws of nature have been fixed since the beginning of the universe, or perhaps nature creates memories that are reinforced by repetition. We can't prove it definitively one way or the other, but there is one scientific fact that no one can deny. A long time ago, every atom in your body was connected to every other atom in the universe. Every atom in you was once part of a common reality, with the atoms in every animal, every plant, every stone, every planet, and every star. And if the smallest particles of existence can remain connected beyond space, perhaps the idea that we are completely separate from each other is just a convenient delusion. And perhaps the greatest mystery is not whether nature has a memory, but whether we have forgotten how to hear it. Thank you for sticking with me until the very end of this story. The theory of morphic resonance remains one of the most controversial and most provocative ideas in modern science. For some, it is dangerous pseudoscience. For others, it is a bold attempt to explain phenomena that official science still does not fully understand. Did McDougall's rats really inherit knowledge? Do animals sense things that we can't measure? Does nature have a memory? Or is there a simpler explanation for all of this that has yet to be discovered? Write your opinion in the comments. Do you believe that all living things are connected in some invisible way? Or do you think this is just a misinterpretation of old experiments? If you found the video interesting, support the channel with a like. This helps these stories reach more people. Subscribe to the channel and press the bell so you don't miss the next documentary investigations about ancient mysteries, forbidden history, UFOs, lost civilizations, and unexplained phenomena. Share the video with friends who love mysteries, science, alternative history, and questions without easy answers. Thank you once again for your trust and for your time. Until the next mystery.